As we look toward the sun, we're awestruck at the enormity of its energy. It overwhelms our solar system, powering Earth's life and dictating the orbits of planets and other celestial bodies with gravity and blinding radiation. Its face burns with fire and light, an active fire pit of nuclear fusion. Yet as potent as it is, the sun is a medium-sized star. When we view the enormity of the universe, we acknowledge that there exist stars much greater and more mighty. Among these is Betelgeuse, a red supergiant that is so vast it overshadows our sun. Betelgeuse resides outside our solar system, within a universe in which cosmic phenomena defy our principles of physics and size. Betelgeuse is also referred to as a pulsating variable star, a red supergiant that continues to fascinate astronomers because it has irregular behaviors. Its vast size is only a part of the enigma. It grows and recedes in sporadic cycles, and its surface frequently erupts with furious activity. Scientists have spent years monitoring Betelgeuse in an attempt to learn not only about its traits but also the forces behind its actions. While conducting this study, researchers came across a disquieting discovery. Betelgeuse might be dying. Join us on a tour of the universe as we travel to Betelgeuse from our location in the Orion constellation. With the James Webb Telescope, we look far into space, studying how this remarkable star can alter our understanding of stellar evolution. From knowing Betelgeuse's structure and life cycle, we gain insights into the destiny of other supermassive stars. As Betelgeuse grows, it may burst into a supernova, spreading elements crucial to life throughout the galaxy. If you are interested in space and its secrets, don't forget to subscribe to our channel, like this video, and enable notifications for more. Interestingly enough, you can observe Betelgeuse with your naked eye during winter in the northern hemisphere. While most stargazers admire Orion's belt or Betelgeuse, many don't realize they're looking at one of the universe's largest known stars. Positioned in Orion's upper left corner, Betelgeuse glows with a reddish-orange hue that makes it stand out among the stars. Its brightness can vary from week to week, catching the attention of observant sky watchers. What might look like a twinkling light is really a star that's changing dynamically from the inside out. If you've noticed this star flashing or changing brightness, you've seen Betelgeuse's pulsations in real time. To the naked eye, Betelgeuse might seem no different than another twinkling light in the sky, but it's considerably farther away and stronger than most stars we can observe. A ways more than 640 light-years from us, its light takes centuries to make the journey across space before entering our eyes. Even at light speed, the most rapid speed any object can achieve, it would still take over 6 centuries to reach it. On our fastest spacecraft, if humanity were to do this, it would take in excess of 12 million years. The trip would last longer than recorded history of humans. This vast distance alone makes Betelgeuse a tough but intriguing subject of research. Betelgeuse's faintness is not merely an effect of its distance. Its status as a pulsating red supergiant implies that it undergoes constant cycles of expansion and contraction. These pulsations are caused by the internal processes of the star, wherein energy accumulates and is released in waves. As it expands, its surface area increases and cools, changing its brightness. These variations are observable from Earth and happen over cycles that span a few months to a few years. Betelgeuse may be fantastically bright at one moment and blend into the background at another, illustrating just how dynamic big stars can be. Astronomers measured one of Betelgeuse's lowest brightness readings in recent history in February 2021, a magnitude of +1.614. Although that number may not be large to those who are not astronomers, it was a dramatic decrease in the brightness of an otherwise luminous star. It created intrigue and worry among scientists who were questioning whether this could be the harbinger of a supernova. Such variability is not unusual to red supergiants, but Betelgeuse's inconsistent behavior makes it particularly intriguing. Researchers still observe its fluctuations in light, attempting to identify signals that would suggest drastic changes within. Such changes could portend one of the most cataclysmic events in astronomy, a star explosion. A second reason Betelgeuse intrigues astronomers is because of its deep red hue, caused by its fairly cool surface temperature. In contrast to our Sun, which burns at approximately 5,500 Kelvin, Betelgeuse's surface temperature is more like 3,500 Kelvin. This cooler temperature causes the star to emit light in the red and infrared parts of the spectrum, giving it a characteristic warm glow. Though it appears dim to us, it's actually much larger in volume. Its size makes up for its lower energy output per square meter. Betelgeuse is the gentle giant of the cosmos, immense and powerful, but quiet and unassuming from afar. In spite of its seemingly serene face, Betelgeuse is a behemoth. It is estimated to be roughly 20 times the mass of our Sun, easily falling into the supergiant category of stars. This massive influence impacts everything from how it produces energy to how it may eventually die. Such behemoth stars have puzzled astronomers for centuries. The ancient Greek astronomer Ptolemy even catalogued Betelgeuse, though he had no idea of its true nature. Its name, derived from Arabic, translates to Orion's armpit. Today, thanks to modern telescopes and technology, we're finally beginning to understand its incredible complexity. The Hubble Space Telescope has been instrumental in capturing high-resolution images of Betelgeuse's outer layers. These pictures show dancing clouds of dust and gas creating patterns on the surface of the star. From this information, astronomers have created detailed simulations to model the behavior of the star. These enable them to forecast changes in brightness, structure, and even its ultimate collapse. ALMA, the Atacama Large Millimeter/Submillimeter Array in Chile, has also helped, offering clues about the gas flows and thermal structures of the star. They cooperate to assemble the jigsaw that is Betelgeuse, a universe's most intricate phenomenon. ALMA's largest find is a gigantic plume of gas rising from Betelgeuse's surface. The material outflow is thought to be caused by the strong pulsations of the star. Far below the surface, convection currents push hot gas upward and cooler gas downward, generating strong waves in the atmosphere. These waves force material away from the surface in spectacular outbursts. This activity not only adds to the star's changes in brightness but also blows mass into nearby space. Betelgeuse is losing its outer layers over time, a harbinger of a potential supernova. These observations are key to understanding the way stars evolve and age. Hubble has also uncovered dark regions on the surface of Betelgeuse called star spots or magnetic spots. These regions are cooler than the surrounding environment and look darker due to intense magnetic fields that suppress hot gas from rising. This is akin to sunspots on our Sun but on a much grander scale. Star spots on Betelgeuse can be several orders of magnitude larger than Earth and can cover up to 20% of the surface of the star. Their rotation and evolution directly influence the visible brightness of the star. These magnetic fields and the resultant dynamics provide astronomers with precious windows into the tumultuous life of supergiant stars. Betelgeuse's magnetic field is among the strongest that have been detected in a star. It has been estimated that it is thousands of times as strong as the Sun's magnetic field. It is so powerful that it entombs gas in enormous loops and arcs that pierce high into the atmosphere above the star's surface. They add to its brightness fluctuations and can be imaged by sophisticated imaging methods. Such magnetic activity is not uncommon. Our Sun has similar characteristics, but Betelgeuse's enormity makes its star spots and magnetic arcs greatly more spectacular. They provide a rare glimpse at the conduct of stars at the edge of size and sophistication. It should be mentioned that Betelgeuse is not absolutely singular in the universe. There are other red supergiants that are similarly constituted, though each with their own idiosyncrasies. One of Betelgeuse's star cousins is Antares, which can be found in the constellation Scorpius. Antares too is a variable red supergiant, with changes in brightness like Betelgeuse. It has around 12 times the mass of the Sun and a radius of more than 700 times bigger, another monster on the night sky. By observing such stars as Betelgeuse and Antares, astronomers are gaining insights into the life cycles and ultimate destinies of massive stars. We leave you now with a question. Did Betelgeuse already go off, and are we merely waiting for the light from that explosion to arrive on Earth? Because it's more than 640 light-years away, any significant event that has occurred there is still en route to us. It's an interesting notion that the night sky could shift overnight if that light ever makes its way. Tell us your theories in the comments. And if you enjoyed this dive into one of the universe's most enigmatic stars, be sure to give the video a like, subscribe to our channel, and keep it tuned for more cosmic findings.